problem, we'd like to solve the equation 2 cosine of 2 theta equals -1. Again, our goal, our variable that we're trying to solve for is theta. It's caught up inside of a trig function. And so we kind of need to work our way out so that we can get out of the trig function. Before we can do anything else, the trig function does need to be isolated. So anything that's going on outside of the trig function, we get rid of using our reverse order of operations to solve the equation. Right now, 2 is being multiplied by the cosine of the cosine function. And so we're going to start by dividing both sides of the equation by 2. So now what I have is that the cosine of 2 theta is equal to -1/2. Now the trig function is isolated, and so the next piece that I want to do towards getting theta by itself is to get rid of the cosine function. The 2 right now here inside is tied up with that 2 theta inside the function. And so when you think of in terms of doing reverse order of operations, where you're kind of getting rid of the weakest link that's the farthest away, we need to get rid of the cosine function first before we can deal with the 2 that's inside here within the inside of the function. So in order to get rid of the cosine, we'd like to think, well, what angles, or we want to think in terms of finding the inverse cosine, which will give us an angle where this is true. In this particular case, if I look at this, I'm looking at where the cosine has a value of -1/2, and I recognize this value as one from my unit circle charts over here. So anytime that you can see that this is one of our common values, it's always great to just go ahead and find those values over here on the unit circle. In this case, we're looking for where the cosine is equal to -1/2. The cosine is our x-coordinate. So we're looking for where the x-coordinate is equal to -1/2. And we find that that happens up here. And we also find that it happens down here. So when we go and we look at what the unit circle values are, where this happens, we end up with having a value of the inverse cosine here that happens at 2 pi over 3 radians. And we also have another one that happens down here at 4 pi over 3 radians. And these are places where the cosine is equal to -1/2. Now, the difference is at this point, when we found these values on our unit circle, we were looking at kind of the inverse cosine idea. But this got rid of the cosine function. However, it still left us behind with that 2 theta. And so what we have here is not values for theta, which is what I'm hoping to solve for, but we have values for 2 theta. So within the unit circle, I have 2 places where the cosine takes on this value. But then what I have to do is I have to take a step back, and I'm going to have to actually finish solving for theta. So we're going to have to divide each of these equations by 2 to get the theta by itself. When I do the top one, 2 pi over 3 divided by 2, what I end up with, let's just do it here. When I divide by 2, that's the same as timesing by 1/2. I can do a little bit of reducing. And that first solution is going to happen at pi over 3. Here for the second one, when I do 4 pi over 3 divided by 2, I can do 4 pi over 3 times 2 over 1, times 1 over 2. So do the reciprocal thing there. And I end up with 2 pi over 3. So in order to solve my solution here, now what I've done is I started with my unit circle values from taking the inverse cosine, and then I solved those for theta. And what I found here is I found my first 2 positive solutions. Okay, well that's really great. However, in the problem here, it asks us to find all solutions. And keep in mind that because of the periodicity of the unit circle, we're going to continue to get values the more that we go around and around around the circle. However, because this value inside here is has a modifier, what we have is we have a modified period. Now, if you remember when we were talking about values within our function, when you're trying to identify what the period of a function is, that b value is, or the period is going to be equal to 2 pi divided by whatever the b value is inside of there. So in this case, my b value is 2, so my period is 2 pi over 2, or my period is just pi. So here basically I'm going through the cosine function twice as fast. I'm going through the entire function within pi radians instead of within 2 pi radians. And what that means here in terms of finding all solutions is that I need to add pi times k to get all other possible solutions, because what I need this time is I need to add multiples of pi since the period of my function cosine of 2 theta is pi. So here, anytime that we go ahead and find our two base values off of the unit circle, we have to do a little bit of solving to get theta by itself. That gets us the pi over 3 and the 2 pi over 3. But then to get all other possible answers, we have to add multiples of the period, which was modified. And so our new modified period is pi. So that's why we're adding pi k here, where in previous problems we've been adding 2 pi k because there was no extra value in front of the theta inside of the trig function. So these would be all of your solutions to this particular trig equation.